An infinitesimally small bar magnet of dipole moment m bar is pointing and moving with a speed v in the direction x cap. A small closed circular current loop of radius a and negligible self-inductance lies in the y-z plane. So the scenario is somewhat like this. There is a circular loop on the y-z plane and there is a bar magnet which is having magnetic moment m bar moving with the speed v. Distance between these two is x and the radius resistance is r. The radius of the loop is given as a. Radius is a. We have to find what is the force opposing the motion of the magnet if the resistance of the loop is high. Okay. All right. So let's try to find what will be the induced current that is induced in this. Right. Induced current. To find induced current, this creates a magnetic field B, which is given by mu naught by 4 pi into 2m by x cube. Right? So mu naught by 2 pi it is mu naught by 2 pi into 2m by x cube. Now this is passing through area of this bigger loop, so the flux would be b into pi times of a square, and the EMF induced is d phi by dt, which is pi a square into dB by dt, which is pi a square into mu naught by 2 pi into 2m into derivative of x bar minus 3. Derivative of x bar minus 3 is given by minus 3 into x bar minus 4. So EMF is 1 pi gets cancelled, 1 2 gets cancelled. It is mu naught into m into a square into minus 3 by x bar 4. So the induced current is EMF by the resistance, which is capital R, which is minus 3 mu naught m a square by x bar 4R. This is the induced current. Because of this induced current, this creates another magnetic moment m dash bar. So m dash bar is given by induced current into area of the bigger loop. That is, again, if you take only the magnitude part of it, it is 3 mu naught m a square by x bar 4R into pi times of r square. That would be 3 mu naught m a power 4 pi by x bar 4R. This is the magnetic moment of the bigger loop, and we have the bar magnet's magnetic moment. Right? What is the potential energy between these two at this particular instant of time? Let's erase this part. Potential energy U equals to minus of m bar dot b bar. Now here m bar is the magnetic moment of the bigger loop dot b bar of the smaller loop. So here there is a dx by dt term which will include the term b as well here. So minus of m bar dot b bar is minus 3, taking only the magnitude 3 mu naught m a power 4 pi v by x bar 4r dot b bar is mu naught by 2 pi 2m by x cube, right? So that would make it as 1 pi gets cancelled again, 1 2 gets cancelled again. Thus u equals to 3 mu naught m square v a power 4 by r x power 7. Now the force, the conservative force, F is also given by minus of du by dx, if you remember from Newton's laws of motion or work per energy. Just taking derivative of this. So this entire thing is a constant except this, right? So which will make it as 3 mu naught m square v a bar 4 by r. Derivative of x bar minus 7 is given by minus 7 into x bar minus 8, right? That would make it as, I'll be writing it here. If you take only the magnitude again, it is 21 mu naught m square v a power 4 by r x bar 8. Right? I think we might have missed a 4 somewhere over here. There is a 4 at the denominator as well. Please include that. That would make it as option A. Right?